Hi, Mihailo.
Hi, everyone. Hi, Kristen.
Yeah, very nice to meet you.
Same here. How are you doing?
I'm doing great. And I just wanted to say I'm really excited to have the opportunity to throughoutly discuss Polygon with you. It's pretty cool, honestly, diving into Polygon from the founder's angle. A lot of people hear Polygon and instantly think Polygon POS. It's almost like the two are one and the same. So from the outside, we should probably get everyone on the same page about what Polygon is all about these days. For our kickoff topic, how about you can walk through Polygon's journey from the OG Polygon 1.0 to the latest Polygon 2.0. We'll explore, what has changed and what has driven these changes. This will give everyone a clear picture of Polygon as it stands today, ensuring we're all on the same page as we dive deeper into our discussion.
Yeah, sounds great. Thank you, Kristen. And as you said, it is indeed an exciting moment for Polygon, and we are excited to share basically everything that is happening in Polygon with our community. So thanks for giving me that opportunity. And yeah, you rightly said that people are still identifying kind of Polygon with Polygon POS chain, which is the first chain and still the most successful chain in the Polygon ecosystem. So it's understandable why people do that. But and we're proud of the Polygon POS chain, and it's still very much operational. We have very excited engineering plans for that chain, so that chain is not going away. But Polygon is a much wider concept now than Polygon POS chain itself. And as you said, the community, we should speak and try to help community understand that Polygon is a much wider concept than the POS chain itself. So let's try to do that. And speaking of these milestones that you're mentioning, there have been quite a few of them, and I'm very, as a founder, I'm very grateful for these milestones. And maybe just a brief recap. So basically, the first one is obviously when we announced Polygon back in 2021, as this kind of idea from the very beginning. When we announced Polygon, we had a very clear goal, what we want to achieve. We realized that the world, the society needs this, so to say, internet of value. So over the past several decades, we have built as a society this global network of information, which we call the internet. And that global network of information has changed the world in very profound ways, right? Our society looks much different now when we have the internet compared to how it looked like before that. And we realize that the world, the society needs similar thing, but for value. So we have global network of information. We need to build global network of value that will facilitate this global permissionless economy. So now we exchange, because we have the internet, we exchange information freely across the globe without any major kind of obstacles. It's seamless. So anyone can send any information to anyone in the world, pretty much. Why don't we have the same thing for value? It can also be very transformational for our society. And blockchain enabled us or gave us kind of the path how we can do that. And we set as our goal, as our mission, to build this infrastructure for this internet of value, to enable anyone in the world to exchange value and program value with anyone else in the world. So that was a very clear goal from the very beginning for us. And we announced Polygon, and we said this is our goal, and we want to build this infrastructure, and that's how it all started. So that's kind of some first important milestone, so to say. After that, we have our Polygon POS chain live already on mainnet, and we started working on it. So this was basically what we already had. And it was a specific moment in time where Ethereum fees were going very high, where you were supposed to pay, for example, $50 to $100 for a single DeFi transaction on Ethereum, and those fees were very high for majority of the people, basically unacceptable. And Ethereum started to lose market share at that point to some other chains like Binance Smart Chain, etc. And this was a very big opportunity for us, which we fortunately took, because Polygon POS chain has very high capacity and very low fees, and it's fully EVM compatible. So it basically has the same user experience of Ethereum, but with much lower fees and higher throughput. And we started working basically on a POS chain and promoting it, and it really exploded in usage. So that's kind of the next maybe milestone, that explosive growth in the usage of Polygon POS chain, and that was very nice to observe basically. And that growth was mainly driven by DeFi applications. So we started seeing all the major DeFi applications from Ethereum deploying, from Aave to Uniswap, to pretty much all major DeFi applications deployed on Polygon. And they saw huge number of users there, usually even double or triple of what they were seeing on Ethereum, because all these users that were not able to afford these high transactions on Ethereum, now they were able to use these DeFi protocols and applications. So we saw all these major applications coming, a lot of capital. I remember back in the days, Aave itself had like $4 billion TVL, so $4 billion bridged to Polygon and deployed to Aave. And in total, I think DeFi ecosystem had like $20 billion or something like that. So really impressive numbers in terms of capital, in terms of users, in terms of applications. So that was very nice kind of to observe, and that put Polygon, so to say, on the map in some way. And that was, again, just the beginning, but another important milestone. That growth of Polygon in popularity and everything else in these numbers, KPIs, led also to a huge increase in token price, fortunately, which basically put us in a situation that we have, like Polygon Foundation has, I think, roughly $2 to $3 billion in the treasury at that point. So it's like a pretty significant amount of capital. And we realized that now we are in position to take the next major step towards that mission that we have from the beginning. So we realized, okay, POS chain is successful, but this is far from enough if we really want to build this infrastructure for the entire world. So we said, until that point, we were in parallel with that growth of POS chain, and even before starting Polygon, I personally have been in the research area primarily when it comes to scaling of blockchain infrastructure since 2017, I guess. And during all this time, we have been evaluating all technologies, all approaches that can actually enable us to build this highly scalable infrastructure. And it mainly has been happening in the field of layer 2, so-called. So I believe our listeners know what layer 2s are. These are basically blockchain scaling solutions built on top of a basic base chain, which is normally Ethereum, which is the most decentralized and most used layer 1, so to say. And after spending quite a lot of time researching all these meaningful technologies and approaches, we developed a very high conviction that zero-knowledge technology is the way to go. So for those who don't know, zero-knowledge technology, or zk technology, is a specific field of cryptography that has very interesting properties that are very useful for what we want to achieve, for building this global infrastructure. And we can touch on that in a moment. Anyways, we developed very high conviction that zk is the way to build this globally scalable blockchain infrastructure for the world. And we decided, that was also another major milestone for Polygon, we decided to go all in, so to say, on zk. And that's when we published our zk thesis, and we said that we believe zk is the future, and we committed $1 billion from our treasury to development of the zk technologies on Polygon. That was a very big decision for us, and it was a little bit risky at that point, because people already kind of knew, there was kind of a consensus in community that zk is the end game. Everyone pretty much understood that this technology has very high potential, and probably we will end up using it as the key technology for this industry. But people were uncertain, how long is it going to take? Like some even experts were estimating that it's going to take, for example, 5 years to build zkEVM, which is one of the products that we built using zk already some time ago, and I'm going to touch on that. But basically, estimates were like, yes, zk is the future, but it's going to take so much to build. It's going to take probably 5 years. It's going to be very inefficient in the beginning. It's going to be very expensive to generate these zk proofs. So some people were skeptical, and we decided to take our bet because, again, we developed strong conviction that this is the end game, and we didn't want to take any shortcuts or anything. We said we are going for the real thing, and we're going all in on zk. That turned out to be a very good decision. After that, after committing that $1 billion from our treasury, we were fortunate to acquire and join hands with three very advanced zk teams, zk projects. One is Hermes, that is now Polygon Hermes. The second one is Mir, which became Polygon 2.0. And the third one is Polygon Maiden. So all these three teams joined basically Polygon ecosystem, started working on different approaches on zk. And what is also very important, they have established very high level of collaboration between the teams. So that was very nice to observe. And these teams started basically working together. Separately, each team has been working on their own solution, on their own approach, but they were highly, and they still are, highly collaborative. So it was very interesting and very exciting to observe that that very strong zk team that started working closely together. And the first outcome of that collaboration was the zkEVM itself. So we deployed zkEVM, which has been considered the kind of holy grail of Ethereum scaling. So basically, zkEVM, for those who don't know, is fully EVM compatible scaling solution. So you can use it exactly the same as Ethereum. It has the same user experience as Ethereum. You can deploy the same applications on it as on Ethereum. So for developers and users, it's pretty much the same as if they are using Ethereum. And it's secured by this zero-knowledge cryptography, which enables very high level of scalability without sacrificing security. So you can reach very high throughput. You can put, let's say, 1,000 transactions or 1 million transactions in a single zk proof. You can prove the correctness of all these transactions, EVM transactions. You submit that one small proof to Ethereum. It gets verified on Ethereum, and you have basically full security of Ethereum and very, very high throughput. So that has been considered basically the holy grail kind of Ethereum scaling. And we were able to deliver it in March last year. So basically, it's almost 1 year now since it's running on mainnet. And basically, as I said, people were estimating it's going to take roughly 5 years maybe to deliver that zkEVM. And we were able to deliver it in a little bit more than a year and a half. So that was the result of these great people that we were fortunate to basically bring to Polygon, and they're working together. We were able to deliver that zkEVM in basically a year and a half instead of 5 years, which is what people were estimating. So it is another very, very important milestone for us. And then the next also major one is that after we deployed, several months after we deployed on mainnet, we announced Polygon 2.0. And Polygon 2.0 is again like a very, very major milestone because it kind of consolidated everything that we have been working on in Polygon. So we started working on these free zk projects, as I mentioned. We started working even on some data availability solutions, several client implementation efforts. So we were really doing quite a lot, and some people got righteously confused. People were asking, okay, what is Polygon doing? You have 10 different projects, 10 different development efforts. How does it all come together? I don't understand. How does it tie with your token? So that was intentional for us. We really wanted to explore multiple approaches, multiple paths to get to this goal that I mentioned in the beginning. When we, again, reached high level of conviction, like we reached high level of conviction that zk is the end game, along the way, we also reached high conviction that this is how the infrastructure and tech stack should look like. And when we announced Polygon 2.0, Polygon 2.0 consolidates everything that we're doing in Polygon into a single tech stack that is powered by our token. And we propose that we upgrade our token from Matic to Pol and give it some new features, some new functionalities, which are very important, some new utility. It basically powers the entire ecosystem of these chains. And that is now the end game for Polygon. We believe Polygon 2.0 is the infrastructure that really can achieve our vision, our goal from the very beginning. This is infrastructure that can support pretty much unlimited number of chains. So we're not talking about Polygon POS anymore. We're talking about arbitrary number of chains that are running in parallel. So you can have 1,000 chains, 10,000 chains, probably 100,000 chains, or even more. Even we can touch on the specific capacity when we talk about AggLayer, etc. But you can have pretty much any number of chains that are running in parallel. So we're talking about huge number of transactions potentially, without sacrificing security. With Polygon 2.0, by using zk, but by using aggregation layer, we are making sure that all these chains, so we can have huge capacity, all of them are secured by zk, and all of them are seamlessly interoperable, which is very important also. Today we have this kind of fragmentation in the layer 2 ecosystem where you have multiple layer 2s, but it's a kind of pain for users to switch from one to another, to bridge assets. It takes time, it's complicated, it's not even that secure. If we want to build this internet of value, the user experience have to be seamless, like it is on the internet today. When you're sending information from someone from yourself to some other person, you don't want to bridge between different servers or whatever, different autonomous systems on the internet. It has to be seamless, right? Like it is today. We need the same experience for this internet of value. And that's something that we are achieving with this architecture of Polygon 2.0. So to wrap it up, sorry for the lengthy answer, but basically this has been the journey of Polygon so far. And we believe we are at the place where we really have the end game infrastructure that can really, again, help us achieve this goal of building globally scalable internet of value.
Well, thank you very much for sharing that amazing journey from Polygon 1.0 to Polygon 2.0, which is going to integrating everything in one place. And that is true. That to understand the Polygon 2.0, I think one very important part, and the part that people talking a lot is about the AggLayer, because it's just get launched and there are projects already integrated in. So this part is just the layer twos. There's a lot of layer twos, and layer two's purpose is to scaling the Ethereum, but there are too many layer twos, making it harder for liquidity to flow freely across all layer twos. That means we were scaling, sure, but not really smoothing things out for users. So if we could get this liquidity issues sorted, would be golden. And that's the whole point of AggLayer, powered by zk Tech. So for this part, it's worth, and lets us delve into the clever aspect of its design and key features.
Of course, you said it very well yourself already, but let's try to expand on it a little bit. So aggregation layer, or AggLayer, is the core component of this Polygon 2.0 infrastructure, and it's the component that ties all these layer 2s together. As you said, today we have this fragmented layer 2 ecosystem and even layer 1 ecosystem. So we have capital and users fragmented across many layer 2s and many layer 1s even. What AggLayer enables is all these chains, even layer 1s, so both layer 2s and layer 1s, to start to plug basically into the AggLayer, and by using zero-knowledge cryptography, communicate with each other seamlessly and become basically a single chain secured by Ethereum. So any layer 2, any Polygon layer 2, and even Polygon POS chain is about to be plugged in the AggLayer. Any layer 1, we have multiple layer 1s already joining AggLayer. One of them is Canto. Some of the listeners will know about that layer 1 chain, and there are some other ones coming. So pretty much any chain can plug into AggLayer, and all these chains that are part of this AggLayer, so to say, they share liquidity with each other. So liquidity is not fragmented anymore. Any chain can leverage any other's chain liquidity. So it becomes this network effect, basically, where all the chains are now, what we have currently is that chains are kind of competing with each other, layer 2s and layer 1s, to attract liquidity. Here in AggLayer, it's a completely different paradigm. Chains are working with each other, basically. So you don't care which chain will attract liquidity because you can leverage that liquidity. And every chain can leverage total aggregated liquidity of the entire ecosystem. So it's a completely different paradigm. And it's much more powerful, obviously, because you don't have competition, you have collaboration, so to say, of all these chains. So several important features of AggLayer. It can aggregate liquidity. It enables seamless interoperability between these chains. And as we said, it's very important if you want to create this internet of value, we need to make user experience seamless. We cannot require users to bridge assets from one layer to another layer to another layer one. Users shouldn't even know about that. That should all be kind of under the hood. And this is what AggLayer allows for. And we're very excited about it. And again, just to touch on the capacity a little bit, AggLayer, if you really want to reach global scale, we need huge number of chains running in parallel. We want to basically recreate traditional financial system. We have in traditional financial system, we have so many venues or hubs of activity. You have stock exchanges that have thousands of transactions per second. You have, even today, you have crypto exchanges. You have consumer applications like Venmo. You have so many of these venues. You have Visa that generates at least 1,000 to 2,000 transactions per second on average. So you have many of these hubs of activity. And if you want to recreate the traditional kind of financial system in a permissionless way, in that internet native way, we need huge throughput. Single chain can never accommodate that level of activity. Single chain can maybe do 1,000 TPS, maybe even 2,000 TPS, whatever. But we need much, much more if you really want global adoption. So it's very clear that we need huge number of chains running in parallel, and AggLayer allows for that. In some of our tests so far with AggLayer design that we're working on, we even have reached 8,000 proofs processed per second. And one proof can prove 1,000 transactions or even 1 million transactions potentially. So I think you can understand basically the potential total throughput of this system. It's basically huge. So if we can process 8,000 proofs per second, and let's say these chains, for example, currently zkEVM is submitting proofs to Ethereum every half an hour. Even if we assume that these chains are submitting proofs every minute, that means we can support 60 times 8,000, 60, almost 500,000 chains if they submit proofs every minute, which is probably not going to be the case. Let's say they submit proofs every 5 minutes. That means we can support 2.5 million chains. So we're talking about really huge number of activity that AggLayer can support and enable, again, a seamless interoperability without all of that, without sacrificing security. So all these chains are validated by zk proofs and eventually validated by Ethereum itself. So it's a very powerful concept that we have been working on for quite a lot of time, and we are very excited that it's becoming reality basically now.
Wonderful. Understanding AggLayer's design and principle is very crucial. And to clarify its benefits, how about we compare it to well-known projects like Cosmos IBC protocol and Polkadot's relay chain with the XCM protocol? They are all aimed to break down barriers between chains. So what makes AggLayer stand out against these technologies?
Yeah, that's a great question. And there are several current interoperability efforts. You mentioned two of them, and these are good protocols like Cosmos IBC and Polkadot's interoperability protocol. These are good protocols and good kind of engineering efforts. The missing component, or what makes AggLayer different, is the usage of zero-knowledge technology. Again, zero-knowledge is a really powerful technology that is really a game changer in several aspects or in several fields of blockchain design. And one of them is this interoperability, or aggregating all these chains or unifying all the participating chains into one. With these protocols like IBC, you don't have uniform security across the entire ecosystem. We ideally want security to be the same across the entire ecosystem. In these protocols, you have security that is dependent on the chain mainly that is sending information to another chain. So the security of the ecosystem is not uniform, is not homogeneous. It depends on the chain, again, that is sending the information. So if the chain that is sending the information has low security, you cannot really rely on that message that you're receiving, because the chain can revert at a later point. So that message is not really valid, and you already consumed it, and, for example, accepted to give some assets to someone else, and the sender chain in the meantime reverts. So that can cause problems and inconsistency in the system. With AggLayer, it is simply not possible, because it doesn't matter. It doesn't matter how secure a chain is. The chain has to eventually generate a zk proof for the activity, for its local activity. It is mathematically not possible to generate a zk proof if your zk prover is sound. It's mathematically not possible to generate a zk proof for a malicious transaction. So even if you have only a single node, what we call sequencer in layer 2s, and it's not secure, it even wants to do something malicious, it cannot do anything, because it has to generate zk proof and send to AggLayer in order to communicate with other chains in the ecosystem. So, and again, it's not possible to generate zk proof for malicious transaction. So that's the advantage of AggLayer. It ensures security, the same level of security across the entire ecosystem. And you don't care how decentralized is that chain that you're receiving message from, what's going on there. You don't care. All you care is that this chain generated zk proof and submitted to AggLayer, and you can safely consume that message without any concern. So that's major kind of difference between AggLayer and other interoperability protocols. The last important thing about AggLayer is that there's no fragmentation of assets. So when you're bridging assets from Ethereum, for example, if you bridge via 2 different bridges or via 2 different paths in Cosmos IBC, for example, these assets are not really the same. These are 2 different, you can say, derivatives of the same assets that is being bridged, which again increases fragmentation of liquidity and makes user experience worse, because you can hold one kind of version of, for example, USDT, and then you have another version of USDT which is bridged via a different path or via a different bridge, and these are basically not the same assets, and it's very confusing and it's not ideal for end users. With AggLayer, you have these canonical assets across the entire ecosystem. If USDT is bridged once, it's the same version of the asset across any chain in the ecosystem. So you don't have to worry about that anymore. They are not these different, again, derivatives of the same assets in the ecosystem, which makes things harder. So AggLayer is addressing that as well. So these are, I would say, 3 main differences and advantages of AggLayer, and they are all enabled by zero-knowledge technology. That's the key differentiator.
Yeah, well, thank you for your sharing. Me as a non-tech savvy can understand very well.
Okay, I'm very happy people can understand, because I'm trying not to be too technical, and hopefully listeners can understand.
Yeah, and nailing the technical side can really make or break a protocol's rep for being stable, secure, and trustworthy. But getting developers to take a leap with AggLayer is another ballgame. So how can AggLayer makes developers love it? Look at Astar, it was the first to integrate with AggLayer. So how long that integration took, and the user workload, and when dealing with different types of chains like L1, L2, and modular blockchains, what developers need to prepare for?
Yeah, that's a great question. Fortunately, we are seeing high level of interest in joining or plugging into AggLayer. I think founders and communities of these chains are understanding the benefits that we just covered. It's just a clear win for chains to join AggLayer, because AggLayer is not extracting any value. It's just this permissionless infrastructure that allows your community to have high level of security because of these zk proofs, and to have interoperability and leverage this shared liquidity in your chain, in your ecosystem. So I think chains are recognizing the benefits, and we have high level of interest really in joining the AggLayer. This is the early phase for us, and Astar is the first basically chain that joined this shared bridge, this shared environment of the aggregator layer, and we're very excited to see that. But Astar has to do, or had to do, or is doing during this integration now, is a little bit more cumbersome process, because it's the first chain that is joining, so we have to be very careful. We're working closely with them, we're kind of hand-holding them, and there are some additional steps that will not be required in the future. So Astar, the journey of Astar is a little bit more complicated than it's going to be for all the chains that are joining in the future. But the benefit for Astar is that it is the first chain, right? It's the early adopter. So that's kind of the benefit that they're having for having that a little bit more cumbersome journey. Chains that will be plugging in the future have a very straightforward path. There is a component of Polygon CDK, and we didn't mention Polygon CDK so far. Polygon CDK is a software that we produced at Polygon, that we built at Polygon. It enables creation of new layer 2s that can seamlessly join aggregation layer, or plugging existing layer 2s and layer 1s into AggLayer. So there's this component of Polygon CDK that interfaces with the AggLayer itself, and all you need to do basically as an existing chain is to leverage that component that is interfaced basically with AggLayer, and you will be able to join pretty much seamlessly. There is a team at Polygon Labs that is assigned to help all the chains to join the AggLayer, especially now in the early phase. And with time, I think that help won't be even needed. I think joining AggLayer will be completely permissionless and very easy, again, using Polygon CDK and that specific module that enables to join the AggLayer. So joining the AggLayer is going to be a very seamless experience, basically.
So how long will it take to integrate? Like one week or two week or a month?
Currently, we're talking about a period of roughly 1 week. I think that's what effectively took Astar to join. You need to do some tests and then finally enable mainnet transactions. So I think roughly a week, and very soon that integration period is going to go down to, I think, 1 day. And soon after that, when we can remove some of these training wheels and some kind of intentional limitations that we're putting in this early phase on new chains that are joining, that can become a matter of hours, probably. At some.
Wow, that's amazing. So if there are going to be more projects that want to join at this stage, so should they dive straight into the technical details, or is reaching out to you guys first a better step?
I would definitely reach out to the team at Polygon Labs. There's a very capable team in Polygon Labs that is very willing to help onboard any new chain. So there's and when a chain is joining, there's usually that kind of business part of the deal and technical part of the deal, so to say. So we have both technical team and business team at Polygon Labs that are both are very excited to speak with new chains that are willing to join. So yeah, I would probably encourage any new chain, any new community that wants to join, to reach out first to Polygon Labs and get some help and initial information. You don't have to do that, definitely. You can read, there's available documentation online. You can start process by yourself. It's definitely not a requirement, but this is only just some free resources and help that is provided by Polygon Labs. So I just encourage everyone to reach out.
Okay, great to hear. We're also curious about which projects are lining up or planning to integrate with AggLayer.
Yes, there are. I don't check the latest data, but there is definitely 30 plus for sure chains that are interested in joining, and it's certain point in the integration process. We have 15 chains I checked yesterday that are in the testnet phase already, preparing to join. Like, this is basically the final step before joining the AggLayer on mainnet. So there are 15 chains there. And again, many more that are lined up and interested. We have several very big chains that are in the negotiations phase, and hopefully we can publicly share these names in the coming week or two. Maybe by the time we publish this interview, one or two of them will be already public. So yeah, there's a high level of activity, and we're very excited for that.
Yeah, very excited to hear.
For example, like IMX chain, which is a big gaming ecosystem, the biggest one, they are confirmed as a user of AggLayer. They are in the final stage, basically, of integration, and there are really several other big names that we are very happy to share soon.
Yeah, and can't wait to see them all get integrated.
Yes.
I think next we will touch on Ethereum and the Bitcoin ecosystems. Bitcoin has a ton of liquidity. Before expanding Bitcoin's capacity often meant melding it with Ethereum. But now with tech advancements, Bitcoin-based layer 2 solutions are starting to get attention. So it makes me wonder if AggLayer might consider integrating with Bitcoin layer 2s, and if that's even possible right now.
Yeah, Bitcoin as a layer 1. So Bitcoin and Ethereum are two most prominent layer 1s at the moment, and as you explained, Bitcoin also has a huge level of liquidity. The issue, the challenge with Bitcoin, there are two basically challenges. One is that Bitcoin itself does not support multiple assets. Bitcoin chain can support only one asset, which is Bitcoin, whereas on Ethereum, you have Ether, which is the native asset of Ethereum, plus all the assets that we already have in the Ethereum ecosystem, all these ERC20 tokens or NFTs, etc. So Ethereum as layer 1 is more expressive, it's programmable, and you can program any kind of asset there and any logic. So that's the first difference. And the second difference, which comes still from the first difference of that programmability, is that Ethereum is able to verify these zk proofs. Bitcoin is not able to verify zk proofs. There are some basically efforts in the Bitcoin community to enable zk proof verification on Bitcoin. I think it would be a very good move for Bitcoin, but Bitcoin community is a little bit ossified in a sense that Bitcoin community is very resistant to any change that would require a hard fork of Bitcoin, and we haven't seen a hard fork in Bitcoin for years already, and I'm not sure how likely is that to happen. And you simply need that if you want to enable zk proofs on Bitcoin. So it remains to be seen. Layer 2s on Bitcoin are getting more popular lately, but the kind of elephant in the room is that these layer 2s are not really secured by Bitcoin. Like if you really want to be secured by layer 1, zk is the way. zk really gives you these strong assurances, mathematical assurances, that your layer 2, that anything that you built on top of this layer 1 is equally secured as the layer 1 itself. If you build something, Bitcoin is very secure. It has a lot of miners behind it. Ethereum is very secure. It has a lot of validators behind it. If you're building something on top, you want it to be as secure as this layer 1 is. Otherwise, why are you using it? So for that to happen, Bitcoin would have to enable zk proofs, and we can observe and see how is that going to go. For now, that's all we can. Otherwise, Ethereum is the L1 of choice for us because of this expressiveness and ability to verify zk proofs.
Yes, and to wrap up our interview, and we are all deeply care about the progress of such project. For those with a huge user base, it's not just about the technical side of things, but also about ensuring the existing communities and network participants are not adversely affected. So all while keeping everything secure and certain. So taking Ethereum as example, it took 6 years to shift from POW to POS. So how long is it the transition from Polygon 1.0 to 2.0 expected to take place? And what steps remain for AggLayer?
That's a very important question, of course, and it's going to take way less time for Polygon than it took for Ethereum. We have been working on these components for a while now, on all these components for several years. And as I mentioned previously, we had this long exploration phase where we pretty much experimented with all the components of Polygon 2.0. It just with Polygon 2.0, we're putting them all together in one single consolidated tech stack. So there are several layers in Polygon 2.0, and let me try to cover them very briefly. So the first layer is the staking layer. In the staking layer, you have this upgraded token of Polygon. So we're migrating from Matic to Pol, which is the new native token of Polygon. You have this staking layer, which is a native restaking layer. So similarly, I think some of the people from the community will definitely know about AggLayer. And AggLayer is enabling restaking of Ethereum, of Ether. So on Ethereum, you stake Ether, which is the native asset of Ethereum, and you can validate Ethereum chain. You can generate some yield. AggLayer allows to take that Ether that is already staked and restake it to validate some other service. It can be some layer 2 or data availability service or something. And that allows you as Ether holder to generate more yield. So you're generating yield by validating Ethereum. And with AggLayer, you can start validating some other services as well and get, for example, transaction fees from there or some token rewards. So basically generate more yield, which is a very interesting concept. In Polygon with staking layer, we have that built into the protocol. So AggLayer is building on top of Ethereum protocol and trying to enable restaking of Ether. With staking layer in Polygon, we have that built into the protocol. So you stake Pol tokens once, and you can validate as many chains as you want. You can restake and validate zkEVM that is going to be decentralized very soon. You can validate Polygon POS chain. You can validate, for example, IMX chain in the future, etc. So you can validate as many chains as you want, and you generate that many revenue streams. So you can basically validate 20 chains and get 20 revenue streams, and that can have that can allow you basically huge amount of like significant yield or return on the work that you're doing in the ecosystem. Staking layer is completely designed, pretty much completely implemented. We have it on testnet at the moment. We believe the first deployment should happen in Q2 or Q3 this year. So we're talking about several months from now. So it's very close. So that's the first layer. The second layer of Polygon 2.0 is the interop layer, which is the AggLayer. AggLayer, the first version, the first component, this shared bridge, we deployed on mainnet, I think roughly 3 weeks ago. So the first component is already deployed. And the aggregator itself that accepts these zk proofs and aggregates them into one is going to be deployed in the next 2 to 3 months max. So that's also pretty much around the corner. The third layer of Polygon is the execution layer. And execution layer, there is nothing particular there. It's just the layer that accepts transactions, generates blocks. It's the equivalent of what we have today in these Ethereum clients. So we are repurposing Ethereum clients like Aragon, like Get, and they are used in the Polygon ecosystem because Polygon is Ethereum compatible. So execution layer is already done basically because we're repurposing existing clients of Ethereum. And the fourth layer of Polygon 2.0 is the proving layer. That is that zk layer that is already in production. Again, zkEVM we have for 1 year already in production. We're just working on new upgraded versions. Like roughly a month ago, we announced the new version of zkEVM, which is the type 1, which is the most basically advanced version of zkEVM itself. So we're constantly improving, but that layer as well is delivered, you can say practically. So now we briefly covered all 4 layers, and you can see that all 4 will be active within 3 to 4 months from now. And then we just have several, of course, iterations and improvements along the way, but it's going to be live. The entire stack of Polygon 2.0 is going to be live in Q3 in the worst case, I would assume, and in the best case in, let's say, 3 months from now. So we're basically almost there. There's no need to wait for several years more.
Yeah, I think the community will be excited to hear your roadmap, your plans, and they are all asking questions like, well, when we can expect them to be launched. I think they're going to be very happy to hear what you said.
Yes, hopefully.
Okay, thank you very much for your time, and we are very happy that we got a whole picture of Polygon and the AggLayer, and may everything a great success. And thank you very much for your time and for your insights.
Thank you, Kristen. My pleasure to be here, and I'm very happy if listeners get to understand and get a better picture of Polygon now.
Okay, see you.
Bye-bye.